Okay, so going over the review. First, we're looking at whether something has exponential growth or decay. First of all, number one is not even an exponential function. An exponential function looks like a number to the power of x. That's not what we have here. So this is neither. This is what we did last unit. This is a polynomial. This is not exponential. Okay, the way we tell if an exponential graph is growth or decay, you take the absolute value of the base. If it's greater than 1, it's growth. Take the absolute value of the base. If it's less than 1, it's decay. Okay, so looking at this, your base is -7. What's the absolute value of -7? Just 7. That's greater than 1, so this is growth. 5, what's the absolute value of 5? It's just 5. Basically, guys, these absolute value symbols, these bars make everything positive. Okay? So this is greater than 1, this is growth. Absolute value of 0.2, that's just 0.2, and that's less than 1, so this one is decay. Okay, my base here is 1. That means it's neither. It needs to be greater or it needs to be less, not equal to. So this one's neither. It either needs to be greater than 1 to be growth or less than 1 to be decay. Okay, any questions on this first part? Okay. All right, moving on to this part. This is just from your notes. Remember, log looks like this, base b, your answer, and then the exponent. If you want to go to exponential form, it's b to the power of x equals a. So you just switch it around. So if this has a log, would be log, the 20 goes down here. The answer is 8,000. Your exponent is 3. Exponent is 3. This is log, base 11. The answer is 14,641. The exponent is 4. This is log base A of C equals B. You're just going back and forth between the two formats. Number 9, you're just going the other way. What's my base if it's not written? 10. So this is 10 to the power of 7 is 10 million. This is 6 to the power of 3 is 216. This is P to the power of R will give you Q. Any questions on that section? Okay, great. Y'all did good on that part. All right, now let's talk about evaluating. And you don't need a calculator for this. Guys, if the base is blank, I should imagine a 10 there. So 10 to the power of what gives you 100? 2, so the answer is 2. 10 to the power of 2 gives you 100. 5 to the power of what gives you 5? 1. Okay, this is where some people got stuck. Normally, let's pretend this negative wasn't here. What would your answer be? 3, because 3 to the power of 3 is 27. Is there a number that will give you -27? If you did 3 to the -3, what would your answer be? Right? Because this will go to the denominator, and that's just 1 over 27. So nothing really gives you -27. So guys, please write this down. You can't take a log of a negative number. This does not happen. If you get something like this, the answer is undefined. You can't put a negative number inside of a log, okay? So this answer is undefined. I'll write that down. The answer here is undefined. We don't take logs of negative numbers. Next one. Okay, 2.7 to the power of what will give you 1? 0, because anything to the power of 0 is 1. Okay? Don't let this fraction throw you off. 2 to the power of what will give you this 32? 5, and since it's in the denominator, what do you know? It's negative. There you go. So look, guys, 2 to the power of -5 you flip it so that it'll be positive 5 in the denominator, and this is 1 over 32. So your answer was negative 5. Okay, so guys, my question is 64 to the power of what gives you 1 over 8? Negative 1/2. Good. The answer is negative 1/2. Remember, guys, if I put a negative 1/2 here, how can I write this 1/2? Isn't that the square root of 64? That's how you get the 8. But since it's negative, it goes into the denominator. Okay. So let me do this step by step. When you have a negative as your exponent, this will go to the denominator. So 1 over 64 to the power of 1/2. And this can be written as the square root of 64, which is just 1 over 8. So that was your exponent. Okay. All right. I'm going to skip 25. Y'all should have that one. Let's do the last two because these two might be a little tricky. I know those are decimals and that looks a little scary. So let's deal with some numbers that we know. Let's just think of this as log base 4 of 64. If this was the problem, what would be the answer? 3, right? Because 4 times 4 times 4 is 64. So for this one, the answer is 3. Let's try and see if that's the answer for the other one. So let's try to do 0.4 times 0.4 times 0.4. See if you get 0.064. You do? Perfect. So this is also 3. Okay, next problem. I'm going to turn this into an exponential. I want to know what the answer is. So this is 5 to the power of what will give you this answer? 5 to the power of what will give you this answer? What should I put in the box so that they match? The same number. I want these to match. So this is negative 0.456. So the answer is negative 0.456. All right, going over the back, I'll just do 2 of them. I know that this is growth and it's facing down because of the negative reflections. I also know this is my asymptote. So I'm going to go ahead and plot my asymptote at 4. Here's 4 on the y-axis. And normally growth looks like this, but since there's a negative in the front, it's going to reflect across the x-axis. So it'll look like this. So that's what my graph will look like. So let's talk about different things. I'm going to talk about the end behavior. The end behavior. So as x goes to the right, what's happening to my graph? As I move this way, what's happening? Yep, it's going down, negative infinity. Okay, as my x values go to the left towards negative infinity, what happens to my graph? Yep, it goes towards 4, the asymptote, as I move to the left. So this is 4. Okay, your domain is always all real numbers. What's your range in this scenario? Exactly, y is less than 4. Everything is below that asymptote. You could also put negative infinity to 4 because you go from the bottom. The bottom is pointing to negative infinity, and then it goes up to the asymptote, so 4. You can write it both ways for the range. And equation of the asymptote. So the equation of the asymptote is y equals 4. This is the asymptote. All right, let's do number 29. This is also a growth. My asymptote is at 2. So your asymptote is at y equals 2. That is right here. And it'll look something like that. So your domain is always the same, all real numbers. However, your range, what is it this time? Good. How else can you write it?
Parentheses -4. I mean negative.
We're right here. Where's the bottom? 2, and where's the top? Infinity. So that's how you'd write your range. There you go. Okay, this one, guys, is this growth or decay? This is decay. So normally your decay graph will look like this. However, you have a negative on the x. When you have a negative on the x, this means it's going to reflect across the y-axis, not the x-axis. If there's a negative in the front, that's reflecting across the x-axis. But since it's on the x, it's going to reflect across right here. So normally it would look like this, but since it's reflecting across here, it's going to look like that. Okay?
But it's still decay.
It's still decay. All right. And your asymptote is actually at -6. So let me write that accurately. 1, 2, 3, 4, 5, 6. So down here, and your graph looks like that. That's it. The points could help you if you're not sure which way to graph it. Your points could help you. You can make a table if that helps. I don't care though. Okay, so that is pretty much a review of everything that we covered involving exponentials and stuff. You guys need to continue practicing condensing. So let me show you what I mean by that. Condensing and expanding and evaluating logs. So, for example, you guys need to know how to do things like this. If I give you log of 1,000, what's the answer? Nope, the answer is not 10. It should be 3. Because what should y'all imagine down here? 10. 10 multiplied by itself 3 times will give you 1,000, right? 10 times 10 is 100. Times another 10 will give you that 1,000. So you need to practice evaluating logs, like we did on the previous page. Also, the properties of logs. So if I give you something like this, log 3 4x plus log 3 7 minus log 3 5. You guys need to be able to condense that into one log. So this is a condensing problem. You need to condense. And then an expanding problem. You guys need to know how to expand. So for example, log of root 3x squared times y divided by z to the 5th. You guys need to be able to expand that. So I'm going to let you guys try it. Try those two. All right, so what you should have gotten, I know that I can bring this as an exponent, so I'm going to put it up here. That's using the power property. And then I can use the product property. I moved the 8 to the top. There you go. Now I'm going to use the product property and multiply these two. So I'm going to make it 1 log with the same base, and I'm going to multiply the insides. So this will be 4 times 7 is 28, and then I have x to the power of 8. And I'll bring down the minus log base 3 of 5. Now I'm going to write 1 log, 1. These have the same base, so I'm going to write 1 log, log base 3, and I'm going to divide the insides. So this will be 28x to the power of 8 over 5. That's your answer. Make sense? All right, now we're going to expand. So I can, first of all, whenever I see a cubed root, I can erase this and turn it into the power of 1/3. Okay? And you can multiply those two. 2 times 1/3 is just 2/3. So I'm going to write this as 2/3. All right. So guys, this is a division. So I'm going to use the quotient rule. I'm going to come on this side. I have log of x to the power of 2/3 times y minus, because I'm doing the quotient rule, log of z to the power of 5. Okay, and I can do the product rule here. So this is log x to the 2/3 plus log y. And you still have minus log z to the 5th. Now, when we're expanding, do not leave these exponents up here. You need to bring them to the front. So your final answer will be 2/3 log x plus log y. Bring this 5 to the front, minus 5 log z. This is your final answer. Just the thing, guys, an important fact is that, remember, you cannot plug a negative into here. What would the answer be? Undefined. You cannot take the log of a negative number. Something like this does not exist. Okay? No negatives on the inside.